Okay, hey guys. So this video is about the product and quotient rules. We just finished talking about the chain rule, and now are next to our product and quotient rules. So I apologize. I just tried to start your video and I screwed it up. So this is already written on, and I'm sorry about that. But we have f of x and g of x. If h of x is equal to f of x times g of x, then to find the derivative, we take the derivative of our first function and we multiply it by the original second function. So notice this is just the normal g of x. Okay? Then we take our normal f of x and we multiply it by the derivative of the second function. I know it looks a little weird. I promise when we do one, it makes a little bit more sense. Okay? Let's look at what the derivative of a quotient would be. So if we have that h of x is equal to f of x over g of x, then if we're trying to find the derivative, h prime of x, all right, it looks an awful lot like our product rule at first. So we're going to do f prime of x times g of x. So the derivative of our first function times our second function. But now we're going to actually do minus, because this is the quotient rule. So minus f of x, our original first function, times g prime of x, so times the derivative of the second. And this is going to be all over the bottom function, so g of x squared. So we have the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. I know that's a lot of information and I know it looks really weird. So one shortcut that we have to help you kind of remember this, Ms. Vasta sings it as a song. I don't sing it as a song, sorry. But you're going to do, she does it as low times the derivative of high. So low meaning the bottom function, and high meaning the top function. So the bottom function, that's our g of x, times the derivative of the top, so times the derivative of the high, minus the high function times the derivative of the low function, so the derivative of the bottom, all over low squared. So it's low d high minus high d low all over low squared. So again, low means bottom, high means top. So low d high, low times the derivative of the high, minus high d low, so the high, the top, times the derivative of the bottom, all over low squared. Again, I know it's a lot. Bear with me, okay? So let's actually look at what this really looks like in a problem. So f of x equals x squared plus 1 times x to the third plus 3. So my first function is x squared plus 1, and my second function is x squared plus 3. So this one is going to use the product rule. So f prime of x is going to equal, I need to do the derivative of my first function. So the derivative of x squared plus 1 is just 2x. And I'm going to multiply that by my second function, which is x to the third plus 3. I did not take the derivative of this piece yet. Then I'm going to add the next piece, which is my original first function, so x squared plus 1, times the derivative of my second function, So x to the third plus 3, that derivative is just 3x squared. And now this is something that we can actually simplify. So what I'm going to do next is multiply this 2x to the inside. So f prime of x equals 2x to the fourth plus 6x. And over here I can bring this 3x squared inside. So plus 3x to the fourth plus 3x squared. And then I can simplify. F prime of x is going to equal, those are my like terms there, so I have a 5x to the fourth plus 3x squared plus 6x. And that is my derivative using my product rule. All right, let's look at a chain rule. So I'm going to go ahead and write my chain rule up here just as a reminder to myself. So it's low d high minus high d low all over low squared. Okay, so when I do the derivative here, I'm going to start with my f prime of x, obviously. And I know I'm going to have a big, huge fraction, so I'm going to go ahead and write that first. So my top function, my high function, is this x squared minus 1. And my low function is x squared plus 1. So low, which is x squared plus 1, d high means take the derivative of the high. So x squared minus 1, that derivative is 2x. Minus the high, which is x squared minus 1, times d low, so the derivative of the bottom, which is 2x. And then it's all over low squared, which means x squared plus 1 quantity squared. All right. Now, sometimes with quotient rule, we don't have you guys simplify, and other times we do have you simplify. It kind of depends on the problem, and it kind of depends on how your algebra skills are. So from here, the rest of this is algebra. But on the AP test, they may give you an answer that looks like this, or they may give you the simplified version. So you do have to be able to do it. So f prime of x, we can simplify this on the top to be 2x to the third plus 2x. And here we would have minus 2x to the third plus 2x. Be careful with your negative. All right, this is a minus, and I'm really distributing this 2x. So I kind of distributed a negative 2x all over x squared plus 1 squared. So f prime of x is really just going to be 4x over x squared plus 1 squared. And that's my final answer for that one. All right, it's a lot of work, I know, but hopefully you guys are with me still. Let's take a look at number 3. So for number 3, my first function is 1 plus t. And my second function is the square root of t. So the first thing I'm actually going to do is rewrite this function so that it's 1 plus t and then times t to the 1/2 power, because that makes it a little bit easier for me to see where I need to take the derivative and what I need to do to take the derivative. So again, this is my first function, this 1 plus t, and t to the 1/2 is my second function. So s prime, I'm going to need my product rule. So I take the derivative of the first function, so 1 plus t, that derivative is just 1, times my second function, which is the square root of t, so t to the 1/2, plus my original function stays the same, so that's a 1 plus t, and I'm going to multiply by the derivative of my second function. So times, I can drop my 1/2, and now it's t to the negative 1/2. and I'm going to go ahead and simplify this. So s prime is going to equal, I'm going to go ahead and just rewrite this right away as the square root of t plus this t to the negative 1/2, we're going to drop it like it's hot. So we get a 1 plus t on the top and then a 2 square root of t on the bottom. And we're actually just going to go ahead and leave that as our final answer. So that is our s prime for number 3. Okay, number 4, we're going to go ahead and get started on that. So my high function is x to the third plus 2x squared minus 1. And then my low function is x plus 5. Okay, so y prime is going to be a big, huge fraction. So I'm going to go ahead and do that first. And I need low d high. So low times the derivative of the high. So that means x plus 5 times the derivative of the top, which is 3x squared plus 4x, minus low d high. So, I'm sorry, high d low. So the top is x to the third plus 2x squared minus 1 times the derivative of the bottom, and the derivative of the bottom is actually just 1, all over low squared. So x plus 5 squared. All right, this is probably one that we would have you just leave because I can see from here that you know the quotient rule. But again, just to work a little bit on those algebra skills, I'm going to go ahead really fast and go through this one. If you want to go through it a little bit slower in class with me, that's fine. But we're going to get y prime equals 3x to the third plus, that's a 4x squared and a 15, so 19x squared plus 20x minus x to the third minus 2x squared plus 1 all over x plus 5 to the second. So y prime is going to equal 2x squared, 2x to the third plus 17x squared plus 20x plus 1 all over x plus 5 squared. And that's our final answer for that one. So again, we'll kind of let you guys know when we need you to simplify and when we don't. But again, from this step here, this is all just the algebra stuff. So I need to know that you can do the calculus, and then sometimes on the AP exams you'll have to have it simplified. So it'll just depend on the problem. But we'll get tons of practice with this. This is not going away anytime soon. So if you have questions, please make sure we talk about them in class. I'll see you guys soon. Bye.